All right, let's continue our extreme value hunt. All right, so we're still using the candidates test with new examples. In fact, now it looks like we actually do have a rational function. And then we also have a trig plus function, right? It's a sign with a linear bit added to it. It's really fun. All right, so, and we do have these domains, of course, the closed intervals that we are looking at these for. So first thing we need to check for, right, we need a continuous function on a closed interval. And so the first one, we might be a little bit nervous. H does appear to be rational, which means it will have a vertical asymptote because this denominator can equal 0. We're going to have a vertical asymptote at x is equal to -3. Thankfully, -3 is outside of the range of things that we care about, right? We only care about from -2 to 1. So from -2 to 1, we've got continuity. Our interval is closed. We are ready to use the extreme value theorem. If we want to think about it, we could plug in and see, all right, we do have a nice little 0 for an intercept. You know me, I like to have a sketch if it's quick. Only if it's quick. If this is not quick to you, don't do it. What else do we have? We can see, ooh, this has a slant asymptote. If I were to do the long division, I'd end up with x and some change for that linear. So it's going to go off linear with a slope of 1. I'm just thinking about long division wise. X plus 3 dividing into x squared, which will leave me with an x. Then I'll have an x squared, right? And then you subtract all that up. The rest of it doesn't matter. What matters is that first term. So all I have to do is divide these two to be like, ha, that's the end behavior. Slope of 1, linear. Cute. All right, so this graph must do something like this, going off towards a slope of 1. And the only way for me to approach that asymptote is to do this. Other side is then, oh, that's a great question. What is the other side doing? Maybe let me think about this for a second. Because I need to finish off negative, but I only have one intercept. Oh, I've gotten myself into a pickle here, haven't I? I mean, I guess it could do this, but the asymptote's multiplicity is 1, so I don't believe in that. Oh, crap. My 0 has a multiplicity of 2. There you go. Took me a hot second. We've got this. So we do that. There you go, multiplicity 2 bouncing. All right, so sorry, there we go. Like I said, only do that if it's quick. That was not quick, but I'm not gonna start this video over because if you know me, you know that I'm lazy. All right, so we're looking at this little window here from -2 to 1. Feels like to me, thinking about my sketch, which was way too slow, 0 is probably my absolute minimum because I have that bounce at that at the intercept of 0, and the max could be on either side. Quite frankly, I don't know which it's going to be, which of those endpoints. But my guess is my critical value will be the 0. We'll see if there's any other critical values where we go from like increasing. But let's go ahead and actually do the candidates test now that I've wasted a lot of your time. All right, so we know if we're going to do the candidate test, first thing we need is some critical values, which means that we need to have our h prime, right? Our first derivative, low, parentheses around it, d high minus high, d low, all over low. Okay, clean this all up. We'll get a 2x squared plus 6x minus x squared all over this thing, which is equal to x squared plus 6x all over x plus 3 squared. And so if we talk about our critical values, that will be seeing when this thing is undefined. That still happens at our asymptote of x is equal to -3 outside of our domain, so we don't really care about it. We also want to know when the numerator is equal to 0, because that would make my first derivative equal to 0, which is the other way we get critical values. So that we would probably set up with a quick little factoring, right? You can pull an x out of each. This would tell me x is equal to 0 or x is equal to -6. And again, -6 is outside of my closed interval. There's that 0 I said we would get. Okay, and that -6, by the way, has to be that because I was talking about this only way for me to go off towards that slope of 1 on that negative side, I had to do that little U-turn. So that -6 is where that U-turn is happening. But anyways, now that we have all of our candidates, we'll put them into a table. We have our endpoints, -2 and 1. We have our 0. I like putting them in order, but that's me. You don't have to have them in order at all. We're plugging back into the original function to look at these things. So I'm going to start with 0. We already know that one. 0 was 0 because we get 0 squared over 3, which is 0 over 3, which is 0. We'll have a 4 over 1. So that's 4. And then we'd have a 1 over 4, 1/4. Aha. Things have been answered. Our maximum is here. Our minimum is here. We can go ahead and write that out. The absolute max is 4 at x is equal to -2. And the absolute minimum is 0 at x is equal to 0. All right, there we go. One more in the books. It looks like we have one more, like I said, analytic kind of algebraic version with D, and then we've got some graphical things coming up in example 3 or 4. I think it's 4 next.